Welcome to C Programming Lecture 11. In this lecture we will look into functions recursive call, pointers and functions called by reference in C programming language. In a C program, a programmer-defined function invoking itself is termed as recursive function call. Recursive function call works more like repetition loop depending on the checking condition and what quantity to be returned to the location from where the function is invoked recursively. As the first example for the recursive function call, let us look into the C program that adds up the data input through the keyboard and calculates the average. In line 6, double type one-dimensional array of size 10 is declared in the global area before the main function. Quantities declared in the global area of a program are available to all the functions in the program. As the name of the array suggests, the double values input through the keyboard are going to be stored as the elements of this data array. Line 9 is the prototype for the function named dataAdd that can be invoked with 3 parameters and will return a double value. The function and the parameters are named to make sense of what the function takes as parameters and do as the job function. The definition of the dataAdd is written just after the end of the main function in line 25. Within the main function, line 13 declares 2 integer variables, namely end and start. End is the variable to store the total number of data that are input by the user. Start is the running variable that is initiated as 0 to begin with the first index value as 0 to be used to access the elements of the global array data. Line 14 declares a double variable named sum. Sum is the variable that is initiated as 0 to process and store the sum of all the input values. Line 16 and 17 are Printf and Scanf statements that inform the user to input the total number of data to be added. The input integer is stored in the memory location of the variable end. Line 19 is an assignment statement in the main function that invokes the dataAdd function with 3 parameters in the right-hand side. And the double value returned by the dataAdd function will be assigned to the left-hand side variable sum. Variables end, start and sum values from the main function are respectively copied to the variables end, start and sum in the dataAdd function. Note that in line 30, which is the first line of the definition of the dataAdd function, variables end, start and sum are locally declared within the parentheses. Lines 32 to 45 are if-else statements that form the scope of the definition of the function dataAdd. If the condition in line 32 is satisfied, then the statements in the scope of the if statement will be selected. Else the statements in the scope of the else statement will be selected. In the checking condition, variable start is used as a counter with the initial value as 0. And variable end value is the total number of data to be added up. So, the dataAdd function invoked from line 19 and the main function will make this condition satisfied and the scope of the if statement will be selected. Within the scope of the if statement, lines 35 and 36 are Printf and Scanf statements that inform the user to input the first data. The input value is stored in the memory location of the first element of the array data. As data array is declared as a global quantity in line 6, before the main function, every function in this C program has access to it. Line 39 is a return statement that has to return the double value to the right-hand side of the assignment statement in line 19, from where the dataAdd function was invoked. In line 39 the return double value is written as invoking the dataAdd function. Thus the return of the double value to the right-hand side of the assignment statement in line 19 can be done only after the double value returned by this function call in line 39 is available. Thus, line 39 is a recursive function call of dataAdd itself with 3 parameters. In the 3 parameters, Variable end value is still the total number of data to be added. Start value is passed on with one added value to count the next data, and sum value is added with the first input data value. This recursive function call of data add will be a second function call that will declare new variables end, start and sum as per line 30. So the incoming function call, 3 parameters value will be respectively copied to these newly declared variables in the second time data add function call. In the second call as well, if the condition in line 32 is satisfied, then the statements in the scope of the if statement will be selected. Else the statements in the scope of the else statement will be selected. In the checking condition, variable start used as a counter is with the value 1 in the second call of data add, and variable end value is still the total number of data to be added up. So, the data add function recursive call from line 39 in the data add function will make this condition satisfied if the total number of data is more than 1, and the scope of the if statement will be selected. Within the scope of the if statement, lines 35 and 36 are Printf and Scanf statements that inform the user to input the second data. The input value is stored in the memory location of the second element of the array data. Line 39 is a return statement that is to return the double value to the line 39 of the first call of the data add function, from where this second call of the data add function was invoked. In line 39 the return double value is written as invoking the data add function, recursively again. Thus the return of the double value to the line 39 of the second call can be done only after the double value returned by this third function call in line 39 is available. Thus, line 39 is a recursive function call of data add itself with 3 parameters. In the 3 parameters, variable end value is still the total number of data to be added. Start value is passed on with one added value to count the next data, and sum value is added with the second input data value, which will be added value of first 2 data. This recursive function call of data add will be a third function call that will declare new variables end, start and sum as per line 30. So the incoming function call, 3 parameters value will be respectively copied to these newly declared variables in the third time data add function call. Hence, this recursive calling of the data add function itself again and again will continue until the last data value input is received through the keyboard. When the last data is received, the counter running variable start value would have incremented 1 by 1 through recursive call to a value equal to end minus 1. With this, the recursive call the 3 parameters. Variable end value is still the total number of data to be added. Start value is passed on with one added value, which will make it as the same value as that of the end variable value, and sum value is added with the last input data value, which will be the added value of all the data values. This time recursive function call of data add will be an invoked number exactly equal to the total number of data to be added. That will declare new variables end, start and sum as per line 30 for the final time. So the incoming function call, 3 parameters value will be respectively copied to these newly declared variables in the final data add function call. In this final recursive call, the condition in line 32 will not be satisfied, as the start variable value will be exactly equal to the end variable value. Thus, the statements in the scope of the else statement will be selected in the final call. Line 44 is the scope of the else statement, which is a single line to return the sum value, which is the added up value of all the elements in the global data array. This sum variable double value will be returned to line 39 of the previous call of data add function that is waiting for this double value to be returned to previous call. Thus line 39 of all the recursive calls of the data add function one after another will receive the sum double value to be returned all the way to the right hand side of the assignment statement in line 19 of the main function from where the very first invoke of the function data_add made. When the double value from the data_add function returned to the right hand side of the assignment statement in line 19, the left hand side variable sum will be assigned to that value. This local variable sum value, which is the added up value of all the elements of the global array data, is available for further processes in the main function. Line 21. Printf statement displays the variable sum value, which is the added up value of all the elements of the global array data on the monitor. Line 22. Printf statement displays the average value of all the elements of the global array data on the monitor. Display of the execution of the exe file, input total number of data and all the data one by one, and final output are shown in the inset window. In C programming language there is feature to do memory management. Pointers are the handlers that facilitate the memory management. From the time we started declaring various quantities like variables, arrays and structures, we have started doing some sort of memory management like requesting allocations in the RAM and to write or read from those allocated memory address locations. Let us look into this C program that declares a pointer variable of integer type. Then assign the memory address location of an integer variable to that integer pointer. And then write and read from that memory location through that integer pointer variable. Line 8 is written for the declaration of an integer type pointer variable named aptr. Note the asterisk in front of the pointer variable name aptr. Without asterisk it will become an integer variable declaration. It is called a pointer variable, as aptr integer pointer can be assigned with the memory address of any integer quantity. It is a good practice to name the pointer that relates to which variable it is going to point to. A ptr pointer is going to be assigned with the memory address location of the integer variable named a. The type of pointer declaration must match with the type of quantity it is going to point to. The amount of memory a pointer variable needs is exactly same as the type of the variable. So a ptr pointer gets 4 bytes of memory allocated in the RAM, as it is of type integer. This 4 bytes of memory allocated in the RAM is now available for storing the memory address of any integer quantity in hexadecimal. Line 10 is an assignment statement that assigns the memory address of variable a to the pointer variable aptr. Recall the use of ampersand in front of the variable name in scanf statement to point the memory address location. Here the right hand side of the assignment statement is ampersand a, which is the memory address of the integer variable a. As the memory address of variable a is assigned to pointer variable aptr, it will now point to the memory address location of variable a. In the main function, after this assignment statement in line 10, aptr can be used as the memory address of variable a. In line 13, scanf statement integer value input through the keyboard is stored in the memory address location of variable a. Note the use of pointer variable aptr to point the memory address location of variable a. Ampersand must not be written in front of aptr as the pointer is already the memory address of variable a. In line 15, printf statement integer variable a value is displayed on the monitor using the variable name itself. In line 16, printf statement memory address of integer variable a in hexadecimal value is displayed on the monitor using an ampersand in front of the variable name itself. Note that %p identifier is used to display memory address in hexadecimal value. In line 18, printf statement integer variable a value is displayed on the monitor using the content of the pointer aptr, which points to the memory address of the variable a. Note that Asterisk is used in front of the pointer variable name to access the contents of what is stored in the memory address location, to which the pointer is pointing to. In line 19, Printf statement memory address of integer variable a in hexadecimal value is displayed on the monitor using the pointer aptr. %p identifier is used to display memory address in hexadecimal value. Thus, line 10 assignment statement that assign the memory address of variable a to the pointer variable aptr, made *aptr same as a, and aptr same as &a. Display of the execution of the exe file, input integer value and final output are shown in the inset window. Using pointers, C programs can be written for calling function with reference and to request only the necessary amount of memory to be allocated and can be given back to the computer system when the allocated memory is not required anymore. Earlier in this lecture, we have looked into a C program that recursively called data_add function to add all the elements in an array that are input through the keyboard. In that C program, irrespective of how many data are input through the keyboard, we declared a double type array of size 10. There were two cons in this way of handling the data. First, the data input through the keyboard cannot exceed the maximum limit fixed by the array size. Second, if the number of data input through the keyboard is less than the array size, then the program was using unnecessary memory in the RAM. Let us modify the C program using pointers to request only the necessary amount of memory and also release them when the allocated memory is not required anymore. In line 4, stdlib header library file is included in this program as size of function is invoked in the main function. In line 7, one more parameter is added in the prototype of the function data_add. Pointer named data of type double is the fourth parameter in addition to the previous three parameters for the data_add function. So to invoke data_add function, three parameters are passed on as values and one memory address, which is the reference passed on to the pointer named data. Note that the fixed size one-dimensional array named data of type double is not declared in the global area of this C program. Within the main function in line 12, pointer named data of type double is declared. Double type pointer variable can be used to point the memory address of double type quantity. 8 bytes of RAM memory will be allocated for this data pointer as it is of type double. Line 19 is an assignment statement that assigns memory address of the allocated memory location through the right-hand side malloc function to the left-hand side pointer variable data. In C programming language, malloc function allocates the requested amount of memory and returns the memory address of the allocated memory location. Malloc function has to be invoked with the total amount of memory need to be allocated. The total amount of data to be input through the keyboard is available in the variable end. The total amount of memory needed to store all the input data is the total number of data multiplied by the amount required to store single input data. Each data input requires 8 bytes of memory to store double type quantity. There is no need to remember how much amount of memory required to store different types of quantity. Size of function available in stdlib library file will return the amount of memory of any quantity when it is invoked with the quantity. For example, if the keyword double or a double type variable is passed on to the size of function, then value 8 will be returned. Here in the size of function, the parameter passed on is *data, which is the content of the pointer data pointing to. A pointer variable of type double can point to the same type of content. So, the size of *data will return the value as 8. Size of function return value 8 will be multiplied with the variable end value to become the parameter value passed to the malloc function. Thus, The right-hand side of the assignment statement and line 19 will allocate the required amount of memory location needed to store all the data input through the keyboard. The memory address of the allocated location will be assigned to the left-hand side pointer variable data. Note that the pointer data will be the memory address of the location allocated to the first double quantity. Adding 1 to the pointer data will give the memory address of the location allocated to the second double quantity, and so on. In the right-hand side of the assignment statement in line 21, the data_add function is invoked with 4 parameters. Fourth parameter is the pointer data, which is passed on to the data_add function as a reference. Reference is a memory address, and this can be received only by a pointer parameter in the function. Thus in line 34, the fourth parameter is declared as a double type pointer in data_add function definition to receive the memory address passed on by the pointer data when invoked in line 21. Hence, within data_add function, pointer data is locally available to handle the memory address and the content of the location it is referring to. So, the first 3 parameters are called by value and the last parameter is a call by reference. Memory address location, where the data pointer in the main function referring to is now passed on as reference to data pointer in the data_add function. So, within the data_add function, pointer data is available to directly handle the memory location referred by the data pointer in the main function. Line 40 scanf statement receives the input value through the keyboard and store it in the memory address location pointed by the pointer data. Note that no ampersand written in front of data, as it is a pointer referring a memory address. Thus, without any variable declaration, only with the pointers, quantities in C program can be handled for storing them in memory address locations and reading them from memory address locations. The input value will be received as a double type by the scanf statement and store it in the first 8 bytes of memory allocated through the malloc function written in line 19. Within the data_add function, this double value can be read or manipulated as the contents of the pointer using the asterisk operator written in front of the pointer data. In the line 43 recursive call of the data_add function, 2 changes are done with the passed on parameters. First one is related to adding the input value to the variable sum. As the stored input value is accessible through the contents of the pointer, variable sum is added with asterisk data, which is the content of the data pointer memory address. Second change is passing on the reference as the fourth parameter in the recursive call. In the next call of the data_add function, the input value has to be stored in the next 8 bytes of memory allocated through the malloc function written in line 19. Memory address of the second 8 bytes is given by 1 added to the memory address of the first 8 bytes of allocated memory. So, the fourth reference parameter passed on to the recursive call of the data_add function is written as data plus 1. Note that this addition of 1 to a pointer variable will add the number of bytes corresponding to the type of the pointer. As the data pointer is of type double, 8 will be added to the hexadecimal memory address of the pointer variable data. Thus the arithmetic of pointer variables is different from arithmetic of variables. Arithmetic of pointer variable will be carried out with respect to the amount of memory corresponding to the type of the pointers. Changes made to the previous C program with malloc function facilitated dynamical memory allocation of required amount of memory as and when needed in the program. Also, there is feature available in C programming language to give back the allocated memory once the memory is not required anymore in the program. In the main function, after displaying the sum of all input data and their average on the monitor, in line 26 function free is invoked with the pointer data as the parameter. This will release the allocated memory pointed by data pointer back to the operating system. Immediately after line 26, This program terminates, so it is not of a big deal to release the memory back, as it will be automatically given back to the operating system at the termination of execution of any app. Here through the C program, we looked into the combined usage of malloc and free function in C programs that can help with dynamical memory management. Consider situations like processing of on-the-fly big amount of data like automatic driving vehicles and drones. Programs developed for processing data for these systems are required to handle huge amount of data. Any software unnecessarily holding the memory will be wasting the resources, and it can slow down the system and make it inefficient for the overall application. So, care must be taken while developing any software to minimize all unwanted usage of resources. Display of the execution of the exe file, input total number of data and all the data one by one, and final output are shown in the inset window. All the C programs examples discussed in this lecture are provided to learn about recursive call of functions, pointers, and functions called by reference. Try to write C programs yourself to get more practice, experience, and confidence in coding computer programs. In the next lecture, we will see how for loop repetition statement is useful to write C programs that can solve scientific and engineering problems.